All right, let's talk about something that can feel a little intimidating, coding. We're going to strip all that away and start from square one with Python, which is honestly one of the best places for anyone to begin. So let's just dive right in.
Have you ever had that thought where you just wish you could tell your computer exactly what to do? Not just clicking icons, but really making it build something for you or solve a problem that only you have. It sounds kind of futuristic, but it's really not.
And your way into that conversation is a language called Python. Seriously. It was built from the ground up to be an entry point, to get rid of all the confusing stuff so you can focus on your ideas.
So, why Python out of all the options? Well, a few huge reasons. For starters, it's just plain simple to get. A lot of the time, it reads just like a sentence you'd write in English. It's also totally free and open source, so anybody, anywhere can get started with it. And the best part? It is everywhere. We're talking AI, building websites, analyzing massive amounts of data. You name it, Python's probably involved somehow.
Okay, but before we even type a single letter, let's just pull back the curtain for a second. Let's figure out what's really going on when you program something. How do our thoughts actually turn into actions on a screen?
So here's the fundamental problem. We humans, we talk in these rich, complex languages, right? English, Hindi, you name it. But computers, deep down in their core, they only get two things, on or off, 1 or 0. That's it. It's a language called binary. So yeah, there's a pretty massive communication gap.
And that is where Python steps in. It's what we call a high-level language. Think of it like a brilliant diplomat. It's designed to be a bridge, letting us write our instructions using words and rules that actually make sense to us.
Okay, but that brings up the obvious question, right? If we're over here writing in our comfy, human-friendly Python, and the computer is way over there only understanding ones and zeros, how does the message actually get through?
The magic ingredient here is a special program called an interpreter. The best way to think of it is as a live translator at the UN. You write one line of Python, and the interpreter instantly translates it into the ones and zeros the machine understands. And boom, the computer does it. It's this line-by-line thing that makes Python feel so quick and interactive. Okay, so we get the how now. We have our translator. So let's look at the what. What are the actual tools we're going to use to build stuff? It's time to open up the Coder's Toolkit.
The first, and honestly most important tool in that kit, is the variable. The idea is super simple, but incredibly powerful. A variable is just a name you make up to hold on to a piece of information. A great analogy is to picture your computer's memory as a giant, empty warehouse. When you create a variable, you're basically grabbing an empty box, slapping a label on it, and putting your information inside.
So what kind of stuff can we put in these labeled boxes? Well, different kinds of information. The computer needs to know what it's dealing with. Is it text, which we call a string, or is it a whole number, an integer? Maybe a number with a decimal point, which we call a float? Or it could be a simple yes or no, a true or false, which we call a boolean. These are literally the foundations for all information in your code.
Now, storing information in boxes is cool and all, but it's a little boring, right? The real fun starts when we make these things actually interact and do something.
And we do that with these things called operators. They're just the symbols that perform actions. You know most of them from grade school math, right? Plus for adding, minus for subtracting, the little star for multiplication. We also have ones that compare things, like the double equal sign, which basically just asks a question. Hey, is this thing on the left the same as the thing on the right?
All right, theory time is officially over. We've got the concepts down, we've got our translator, we've got our boxes for storing stuff, and we have the tools to make them interact. Now let's put it all together and see what your very first program actually looks like. This is that aha moment. This is where it all clicks. Are you ready to see how these simple little pieces can snap together to tell a machine what to do?
You know what? Let's forget about code for just 1 second. Let's just think through the steps in plain English. First, we need a box, let's call it A, and we'll put the number 2 in it. Simple enough? Second, we need another box, we'll call it B, and put the number 5 in there. Third, let's do the math. We'll add A and B together and store that answer in a new box called sum. And last, let's just tell the computer to show us what's inside that sum box. That's the whole plan.
And this is what that exact plan looks like in Python. Just look at it.
A equals 2, B equals 5, sum equals A plus B, print sum, it's almost exactly what we just said out loud. That's the beauty of Python right there. It's designed to be that clear.
And that's it. Seriously. In 4 clean, simple lines, you took an idea in your head, adding 2 numbers, and you gave a machine a perfect set of instructions to get it done. At its core, that's all coding is. So just think about what just happened. You didn't just read code. You understood the logic of a computer program from start to finish. And the jump from this to building something way more complex isn't some giant leap. It's just learning a few more building blocks and figuring out new ways to put them together. Your journey has literally just started. So the only real question left is, what are you going to build next?